Now we're going to be looking at the critical points and the concavity of the function, but we're going to be using the second derivative system. What are we going to do in the first step is we're going to get the derivative of my function. So we're going to go f prime of x is going to be equal to 3x squared minus 6x. Just like we did before, to get the critical points, I'm going to factorize it. So I'm going to get the 3x as a common factor, and it's going to be x minus 2. So 3x times x equals 3x squared, 3x minus 2 equals minus 6x. So this is giving me that x1 is going to be equal to 0, and x2 is going to be equal to 2. So I'm going to get 0, and I'm going to get 2. Now, to be able to get my inflection point, I have to get my second derivative. So my second derivative is going to be f by prime of x equals 6x minus 6. So if I equal it to 0, I get that 6x equals 6. So x is going to be equal to 6 over 6, which equals 1. And that's going to be my inflection point. So I'm going to have a 1 someplace around here. Now, to get my maximum and minimum critical points, I'm going to have to go and plug in my critical points into my second derivative. So I'm going to go f by prime of 0 is going to be 6 times 0 minus 0, which equals minus 6. Once again, what I care about is the sign. It's a negative. So what I'm going to do is that every time it's going to be a negative, I'm going to say negative, so it's going to be concave down. And if it's concave down, that means that that's going to be my critical point, and it's going to be a maximum. Now I'm going to go f by prime of 2, which is going to be 6 times 2 minus 6, which equals positive 6. So we're going to go, since it's going to be positive, that means that it's going to be going concave up. So that's going to be my critical point, but this case is going to be a minimum. Okay? So now I know that 0 is going to be giving a maximum critical point. So it's going to be 0, comma, something. And 2 is going to be a minimum. So it's going to be 2, comma, something. Okay? So that's my inflection point. So that's where I'm going to start. So when I'm working 0, we said it was going to be concave down. So I'm going to go all the way to my critical point and back down. And when it was 2, it's going to be concave up. So I'm going to go down and then I'm going to go up. So what does that give me? That's giving that it's going to be increasing, decreasing, and increasing again. So increasing is going to be from minus infinite all the way to my critical point, which is 0. Then it's going to go decreasing from critical point to critical point. So it's going to be 0, 2, and then increasing again from 2 to positive infinite. So we're going to go union to top positive infinite. Okay? Now, this one is a critical point maximum. That's a critical point minimum. So that's concave down, and it's going to be concave up. So concave up is going to go from my inflection point, which is 1, to positive infinite. And concave down is going to go from minus infinite to my inflection point, which is going to be minus infinite, comma, 1. Now, to get the values of y, and the 3 points, I'm going to do exactly as we did last time. So I'm going to plug them into f of x. So f of 0 is going to be 0 cubed minus 3 times 0 squared plus 1. So which is going to come out to be 1, right? So that's going to be a 1. Then I'm going to get f of 2, which is 2 cubed minus 3 times 2 squared plus 1. So that gives me minus 3. So I'm going to go minus 3. And then we're going to go f of 1, which is going to be 1 cubed minus 3 times 1 squared plus 1, which comes out to be 0. So I'm going to have 1, comma, 0. And that's everything we had to do.